Neutrophils, T cells, and dendritic cells are our first line of defense against microscopic invaders. To fulfill this role, they must travel quickly and efficiently throughout the body. Most of our cells don't typically move as fast and instead use a slower method called proteolytic mesenchymal migration. As such, the cells in our body move at various speeds, traveling distances of a few microns in times as short as a minute to as long as an hour. Cancer cells, however, can exploit both slow and fast strategies. Exploring the mechanisms by which our cells traverse the body can help us better understand cancer cells. This is a dendritic cell. It navigates the extracellular matrix, or the ECM for short, to reach a lymph vessel and start the adaptive immune response. It swiftly travels the ECM using a mechanism called Amoeboid Migration. The dendritic cell advances without adhering to the environment, a behavior sustained in two ways by actomyosin contractility, the steady role and the transient role. At the cell rear, the protein non-muscle myosin II constantly pulls on filamentous actin, or F-actin. This steady contraction acts as the driving force propelling the cell forward. At the cell front, where protrusions explore the maze of fibrils ahead, F-actin accumulate and are nucleated by the protein ARP23 to create a branched actin network. Since this network exists transiently, the protrusion is maintained by microtubules, which arise from the microtubule organizing center. Now that we know the cell explores the environment, how does it choose the best path? The cell finds the path of least resistance through amoeboid nucleokinesis. The nucleus, being larger and less compressible than other organelles, serves as a mechanical guide to assess if a path can accommodate the whole cell. Occasionally, the cell will choose the wrong path. Most times it will correct its course. But if it attempts to squeeze through a pore that is too narrow, it results in the rupture of the nucleus and in cell death. Let's try that again. This time, it finds the pore is too small and starts redirecting itself to a wider path. Meanwhile, protrusions testing smaller pores are retracted through the depolymerization of the microtubules. Through these strategies, immune cells using amoeboid migration can avoid dense matrix areas to prioritize migration speed over the shortest path. This is unlike cells that use proteolytic mesenchymal migration, which is much slower since it takes time to digest and attach to the matrix. On the other hand, cancer cells may utilize one of these strategies, sometimes switching from one to the other, to ultimately spread to other parts of the body. Overall, cell movement involving immunity and disease are fascinatingly complex, and so acquiring a deeper understanding of these mechanisms can lead to further breakthroughs in cancer therapy strategies.